Good morning, grade 6. Let's have science 6 to begin with. Let me ask Elijah to lead the prayer. Is that the correct pronunciation of your name, Elijah? All right.
So last year, in my grade 10 class, we managed to create an application. So it was
Please lead the prayer.
And then actually
How about Robin? Is that the correct pronunciation of your name? You're lagging.
It's not Robin, it's Robin.
Oops.
Teacher,
Yeah,
it's Robin.
Robin. Okay. Can you lead the prayer?
I don't know the prayer.
Wow.
I don't pray, teacher.
You don't pray?
I'm
Okay,
not
in the name of the Father, the
religious.
Son, and the Holy Spirit. Amen. Our Father in heaven, will be thy name, thy kingdom come, thy will be done on earth as it is in heaven. Give us this day our daily bread, forgive us our sins, as we forgive those who sin against us, not bring us to test, deliver us from evil. Amen. Good morning, class. Okay. Today is our first day of Science 6. Okay. Let me share my screen on a while. Let's have the characteristics of mixtures. Okay. Are we all good?
Yes.
Okay, some of you are lagging. It's okay. I do really understand. This session is being recorded. So if you think that you didn't actually get the discussion, you can always go to your LMS and access discussions, right? Hang on. Can you see my shared screen now?
Yes.
All right. Characteristics of mixture. Okay. By the way, I'm teacher MJ, your science teacher, as well as your science laboratory professor. We will have laboratory works if we are actually allowed to do so, right? Heterogeneous mixtures, okay? A mixture in which you can easily distinguish the components or ingredients is called a heterogeneous mixture. This mixture is actually simple. If you see that the components are distinguishable, meaning to say that you can actually see different, okay? You can actually see different components of that certain mixture. It is heterogeneous. Hetero means many, okay? These mixtures also, you can always observe this one while cooking, okay? When you cook, for example, a frittata, when you cook your food, those are heterogeneous mixtures, okay? What is heterogeneous mixture then? Okay, often have the main component or base ingredient. This is the most abundant component into which the other ingredients are mixed. The main component determines a lot of properties of the mixture. The added ingredients bring in their individual properties in the mixture. Supposed to be we'll have an experiment with regards to this. But again, if we are allowed to do so, we will do the experiment, right? It's just like this. As you can see, what do you observe in the picture? What can you observe in the picture? Looking at the picture?
Different types of candies.
Yes, there are candies there. Nuts, there are a lot of nuts.
Peanuts.
Yeah, peanuts, yes.
Peanuts and cashews and
Raisins.
Almonds.
Yes, there are a lot of almonds also. What else?
M&Ms. There's M&Ms and
Yeah,
raisins.
M&Ms. There are a lot of M&Ms also. Colorful, isn't it? Okay, this is one typical example of a heterogeneous mixture because you can actually distinguish the different ingredients there. Okay, you can see a lot of ingredients there. That is actually heterogeneous mixture. Teacher's voice is bugged. Am I bugged? Can you hear me
Your
clearly?
microphone,
It's a
teacher.
bit
He
bad.
means your microphone.
My microphone?
Yeah.
Okay, wait. I'll just get some microphone. Hold on.
Do, unsi pa nga sinong saya imong gakuan imong
Is he changing his mic?
Yeah.
He had the best mic ever.
Teacher, come back with your mic. It was beautiful.
So you
Yeah.
guys are good humor.
I'm here.
Okay. It
Okay.
sounds the same.
Can you hear me now?
Yeah, that's better.
Okay. All right. Okay, by the way, as a classroom rules, okay, I want my student to be attentive with my class. I am actually not strict. I will be strict if there is a need to do so. Okay. I am not a typical teacher that you're actually thinking of. No. Okay. I am really into discipline. And that's it. All right. I want you to um to act as a grade 6, not a lower student or lower grade level student, right? This is a preparation for you for junior high, preparation for grade 7.
Grade driven.
All right, let's continue. Heterogeneous mixtures in nature. There are a lot of heterogeneous mixtures in nature. If you're going to observe nature, there are a lot of heterogeneous mixtures that occur naturally. Okay, some of them are soil. It's a heterogeneous mixture because you can actually see a lot, or you can see a lot of things in soil, or a lot of components in soil, sand, and rocks. Soil is a mixture of sand, dirt, rocks, and decayed matter. Okay, sometimes bits of metal, cloth, glass, and plastic will be found mixed in soil. Sand is another example of a heterogeneous mixture. Okay, beside the very fine grains of sand, a scoop of sand may have pebbles, bits of shells, glass, and a piece of iron. So if you're going to look at it, again, the heterogeneous mixtures are distinguishable. You can distinguish the different ingredients or different components of that certain mixture. Okay. Do you have any questions so far? Just like in our
Oh,
the soil here
So
has rocks in it, has bits also of white rock. What else? Dead organic matter. So those are the components of the soil, which makes the soil as a heterogeneous mixture. Camera on, everybody. Human-made heterogeneous mixtures. We have also we do also have mixtures do not occur or only occur naturally. They can also be man-made or made from existing ingredients. For example, concrete mix has the following ingredients: cement, sand, gravel, and water. So if you're going to look at it, it is not naturally occurring, okay? Meaning it is artificially created or human-made or man-made. The ratio of each ingredient differs depending on how the concrete would be used, okay? Concrete mix for making posts has much more cement and gravel. Concrete for making smooth walls and floors has no gravel, but has a very fine sand, shiny pebbles, or glass beads that are sometimes mixed into concrete to be used to make patterns on walls and floors, or floors rather. So again, it is not naturally occurring. This is artificially, okay, or man-made or human-made, right? Medicinal mixtures. Of course, in medicine, if you're going to observe medical fields, there are a lot of mixtures also there. Okay, even the most food that you eat are heterogeneous mixtures. Some examples are fried rice, chop suey, pinakbet, and salads. Okay, these are heterogeneous mixtures. To make delicious heterogeneous mixtures, you should mix ingredients that go well together. Okay, some homemade heterogeneous mixtures are used to treat illness. Okay, sap from leaves of plants like calachuchi and mango are mixed with oil to treat skin diseases because calachuchi and mango is proven to have antibacterial property. Okay, leaves of medicinal plants like oregano may be crushed and mixed into warm water to form poultice. The mixture is used over joints and muscles to relieve pain because it has, again, a cold effect. At the same time, it has a relaxing effect on the in the tissues, covered tissues there. Some seeds of plants like papaya are pulverized, mixed with water or milk. The resulting mixture is ingested to help deworming because it has a deworming property. Okay. Medicines have active ingredients. This ingredient possesses the healing component of medicine and is given up according to the need of the person or the patient. The other component in medical mixtures are called additives. There are a lot of additives in medicinal mixtures. Okay, these additives will actually it acts like a catalyst. Catalyst. When you hear the word catalyst, what does or what comes into your mind? Any idea? When you say catalysts. Grade 6, are you still with me? Can you hear me?
Yes.
Okay, based on the
Yes.
statement given there, that additives in medicinal mixture acts like a catalyst. What does it mean? In your own understanding. Hmm? It acts as what? It functions to make the effect faster. Okay? It is a component that makes the reaction becomes faster.
Teacher, you're lagging.
Am I lagging? Am I lagging?
Yes, teacher, you
Yeah.
lagging.
Yeah, kind of.
How about that one?
It's okay.
Okay, again, additives acts like a catalyst. So when you say catalyst, it is anything that makes the reaction faster. That's a catalyst. Okay? Let's move now to homogeneous mixtures. Do you have any question with heterogeneous mixtures? Hetero means many. Question so far with heterogeneous mixtures? Other countries, they pronounce heterogeneous mixtures as heterogeneous mixtures. Question so far with heterogeneous mixtures? Are you still with me?
Yes.
Yes, teacher.
Okay. Let's continue with homogeneous mixtures. When you say homogeneous mixtures, it means to say that you can only observe one. Homo means one. Okay. Mixtures are also called solutions because they mix. Okay. The components or the ingredients there are not distinguished or indistinguishable. Homogeneous mixtures are also called solutions. They are mixtures in which their components or ingredients are not distinguished from one another. Okay, they appear one, indistinguishable. Okay, that's the term. Examples of homogeneous mixtures are dextrose. Okay, your natural saline solution, the one used in hospitals. Rubbing alcohol. Okay, you cannot actually distinguish the alcohol, which is 70%, and the water, okay, which is 30%. Seawater, you cannot distinguish salts and water there, okay, because they appear one. And fruit juices, okay. In a solution, the additive is dissolved and thoroughly mixed in the main component. Its main component is called the solvent. So we have now terminologies, solvent and solute, okay, while the dissolved additive is called solute. Okay, solvent and solute. Solvent is the dissolving agent. Okay, solute is the one being dissolved in a solution. Again, solvent is the dissolving agent, and the solute is the one being dissolved in a particular solution. Water, for example, is a solvent that dissolves many substances. Therefore, this is the reason why it is often called as the universal solvent, because it dissolves a lot of solutes or a lot of substances. Question so far? I want you to ask questions every now and then, all right? If you have questions in your mind. Solubility. Okay. Okay. Some solutes dissolve easier than others. Okay. This property of solutes is called solubility. It is determined by the amount of solute that can be dissolved in the fixed amount of solvent. Like for example, salt, which is 35.7 grams per 100 ml of water at 200 degrees centigrade or Celsius. So we actually dissolved, okay, solubility, we actually dissolved a 35.7 grams of salt in a 100 ml of water and given 200 degrees Celsius temperature. Sugar, which is 200 grams 200 grams dissolved in 100 ml of water at 200 degrees centigrade. So these are examples. The data above shows that sugar is more soluble than salts. Okay, as more sugar can dissolve in same amount of water at the same temperature. Okay, above 35.7 grams in a 100 ml water. Okay, salt, you cannot actually dissolve salt. It is called oversaturation. Okay, or supersaturation. There are examples of powder. There are some examples of there are some powders or solids that do not dissolve, or they are called insoluble in water. Examples are chalk and naphthalene. They are insoluble in water. So salt and sugar are soluble in water, okay, while chalk and naphthalene are insoluble in water. Concentration, okay. Solutions vary in concentration. Concentration can be expressed simply as the amount of solute dissolved in a specific amount of solvent. Again, the solvent is your dissolving agent. Your solute is the one being dissolved in a solution. If you put more solute in the same amount of solvent, the resulting solution will be more concentrated. Okay, that's concentration. Okay, because you are putting a lot of solute in a particular solution. Right? More concentrated solution shows the properties of solute better. putting in more sugar makes your drink sweeter because the property of sugar is sweet. Correct? Putting more sugar in water will make the water sweeter. Okay? Putting in too much salt in your broth makes it very salty because the property of salt is salty. Okay? Concentration can be expressed in percent. You may use the percent sign, concentration, to express how much liquid solute is mixed with the solvent or liquid solvent. Like this one. The bottle of 40% alcohol actually has more water, which is 60% in it, than alcohol. Okay? So it is a dilute. It is a dilute solution. Meaning to say it has more solvent, less solute, making it a dilute solution. Other terms or other pronunciation is dilute. Okay? Thus, a 150 ml bottle of 40% alcohol has 60 ml alcohol and 90 ml water. Okay? Do not feel cheated with this. Actually, all right, you cannot use 100% alcohol as it will be harmful to your skin. At the same time, it will just evaporate. The property of alcohol, if you're gonna place it in a room temperature, it will just evaporate by itself. So you cannot actually use it as antiseptic if it is 100% alcohol or ethanol or ethyl alcohol. Okay? A 40% concentration is enough to kill most bacteria and make your hands clean. But again, your hands will feel moisturized because again, there are a lot of water in it. The bottle with 70% alcohol or ethanol has more alcohol than water. Okay? A 150 ml bottle of this solution has 105 ml alcohol and 45 ml water. Okay, observe this bottle says antiseptic or disinfectant. Again, because it has more solute and less solvent. Okay, this is because 70% alcohol is the concentration recommended for use in hospitals and in cleaning areas around wounds. But be careful of putting alcohol in your wounds, right? Because alcohol or 70% alcohol can actually damage some of the tissues nearby. Solution components, let's take a look at this one. Solving the amount of each component in a solution given concentration in percentage is easy as 1, 2, 3. Here is the solution for a 70% alcohol or 70% solution. Okay, amount of alcohol is equal to amount of solution. Okay, how many ml times the concentration in decimal. So you need to convert what? You need to convert
70%.
Yeah, you need to convert 70% to decimal. How can you convert 70% or how can you convert percentage to decimal?
I don't know.
This is in your lower grade. Conversion. Percentage to decimal, math.
I don't think we learned that in math, teacher.
I will ask your math teacher, right? Okay, in converting percentage to decimal, you need to move towards, if it is in percentage, you need to move from right going to your left. Move the decimal from right going to your left. Okay, this is 70%. Okay, let's move two points or two areas or two digits going to your left. So 1, 2. Here comes 0.70. Okay, so our 70% is converted now into 0.70. So 150 ml times 0.70. The result there is 105 ml. 105, bring down the unit used, ml. Do not forget to bring down the unit being used, ml. So our 70% solution, okay,
has 105 ml of alcohol, pure alcohol. Okay? How about the amount of water? Okay, the formula in order for us to get the amount of water is simple as 1, 2, 3 also. Amount of solution, which is 150 ml bottle. This is the entire bottle times, okay, 1 minus concentration in decimal. Okay, so we converted again the 70% alcohol or 70% into decimal. This is 0.70. 1 minus 0.70 times 150. The result is 45. Bring down the unit used, ml. So the water in your 150 ml 70% solution, alcohol, is only 45%, while the alcohol is 105 ml. That's the component of your 70% solution or 70% alcohol, which has a 150 ml bottle. Any question? Did you get the point?
Yes.
Are you sure? Who has question there? Raise your hands. Okay. You don't have question? Are we
It
good?
seems kind of difficult, but I guess we can understand if we read it more.
All right. We'll be having more examples by next meeting. We still have 5 minutes. Let's discuss this first. Okay. This is same amount can be solved by subtraction. So if we're gonna subtract, okay, the amount of water is equal to 150 ml minus the amount of alcohol, okay, which is 105 ml. The result is 45 ml. That's the amount of water. So where did we get the 150 ml there? Huh? Where did we get the 150 ml?
Water?
The 150 ml is actually from the bottle, the entire bottle itself. It's 150 ml. Okay?
Oh yeah,
That's the entire bottle. The amount of alcohol is 105 ml, which is actually derived from our formula, this one. So we actually subtracted 150 ml with the amount of alcohol, which is 105 ml. And the result is 45 ml. This is your water. Okay, we counter check if our solution is correct. Okay. Concentrations of solutions can be easily changed by adding either more solute or more solvent. Okay, adding more solute increases the concentration because you are creating now more what? It has now more solute than solvent. Adding more solvent lowers the concentration, okay, making it a dilute solution or dilute solution. Let's have this example. Starting from 150 ml of 40% alcohol. Now we have a bottle which is 150 ml and it is actually 40% solution or 40% concentration of alcohol. Let's have this as a rubbing alcohol. What will be the new concentration if 50 ml of pure alcohol is added into the solution? Okay, there is already 60 ml of pure alcohol in the solution derived from 150 ml. How did we get the 60 ml solution? How did we get the 60 ml here? Based on our formula. How did we get the...
What?
Yes, John Michael.
From pure alcohol?
Yeah. Originally, it has 60 ml pure alcohol in the solution. Okay, how did we get the pure alcohol there, the 60 ml? Huh? Based on the formula that we have here, okay, we computed, or the formula in getting or in extracting the amount of alcohol is the amount of solution times the concentration. So the concentration here is 40%. So 150 times, convert this into decimal, 150 times 0.40, the result is 60. So we have 60% pure alcohol. And the question here, what would be the concentration if we add another 50 ml? So 60 plus 50 pure alcohol, or 50 ml pure alcohol, the result here is 110 ml of pure alcohol, okay, in a 200 ml solution.
So there's 90 ml water.
Where did you get the 90 ml water there?
Because 110 ml of alcohol. Or am I looking at it wrong?
The question there in the problem states that what will be the new concentration if 50 ml of pure alcohol is added into the solution?
55%.
55%. How did you get the 55%?
From times 100.
It's 110 divided by 200. This is the this is the solution, 200 ml times 100, which makes it 55% solution. Okay, we added 50 ml pure alcohol. We also added